Hello everybody and welcome back. In this video solution, we are going to talk about the problem insert, delete, get random order of 1. It's a very famous interview problem, very commonly asked in interviews, so let's get started. The goal of this problem is to implement this randomized set class. Now, what this class is going to have are three different functions: insert, remove, and get random. Each of these should be able to insert some particular value inside of the set. This should be able to remove this particular value from the set. And the getRandom function, which is the most interesting function, returns a random element from the current set of elements. And each element should have the same probability of being returned. Now, if your first instinct was to create a set and start to think about from that point, that was my same instinct too. I created a set and then I wrote down basics insert and the remove function. Both of them are very standard, very symmetric in fact, but the getRandom function is what is going to give us the issues. Because in Python, if you do random.choice of this set, this will give you an error. Let me show you. You see, the set object is not subscriptable, and to return a random choice of elements, Python uses CPython, and it calls the self._rand below function, which is going to take the length of the sequence and return some index which is between 0 and the length of the sequence. And it is going to index the sequence by that index. However, if you realize sets are not indexable, these are not subscriptable. What it means is to fix this issue, we'll have to create a list from it. And this will work. So great, we're done, right? Let's quickly look at the time complexities. This is going to take order of 1 time. Inserting on an average case, insert is order of 1 for set. Similarly, remove is also order of 1. This getRandom function would have been order of 1. However, converting it to a list first is going to take order of n time. And the goal of this function is to return this order of 1 time. Clearly, using a set will not work because we'll have to convert it to a list. Okay, since we know that this line is the one giving us all the trouble to convert this set to a list first, how about this? How about instead of having a set at all, let's just have a list. We'll call this listed data list, and we're going to store that as a list in the init function. Now we can also do this insert function saying that, if value is in the self.data, and return false. And if it's not, just go ahead and do self.data.append the current value and we can return true. However, this operation, this value in self.data is order of n. See, we have fixed this issue. This is order of 1 now. This is no longer order of n. This is perfect. But in fixing this, we have sort of disturbed this insert function. And this is now giving us order of n time. Because to find out if value is in the self.data or not, we have to iterate over all the elements. Now that does not sound too good. And so we need a way to figure out if a value is inside of this data structure or not. We are looking for a data structure that can help us find this very quickly, perhaps in order of 1 time. Now we can of course use another set over here, but we're going to use a dictionary. And I'm going to explain that later on why this dictionary becomes so important. So we are going to create a dictionary which is going to have these elements as the keys and the values as indices. That's fine. So instead of iterating over all the elements in self.data, I can just do a self.dcheck that can instantly return me whether this value is inside of the dictionary or not. Now, if it is in dictionary, we'll return false right away. If not, we're going to self.append this particular value and do self.d of val equals to the current index. We're going to set the index to be the length of the self.data. Okay, great. So we're done with the insert function. All of these operations are now order of 1 average. Similar to the first line in the insert function, we are going to check if value in self.d. Now if value not in self.d in this case will return false. If it is there, however, we want to return true and do some compute here. The first thing I would want to do is let me extract out the index sitting at this particular value. Maybe this becomes important later on. Okay, we have the value and we know that we have to delete this self.d's value later on. Okay, cool. We're set up with the basic things. Now here's the thing. At this point, you can go ahead and do this self.data.remove this value. You can do this operation and this is going to remove this particular value from the data list. Now I actually want to show you how this is going to work. Let's say the data list is 14532 and the dictionary given to us is this. Basically, for each element, we have this index stored. So 1041523324. Okay, great. This is the current setup now. Let's say that the request comes that we want to remove 5 from inside of this data structure. How do we do that? Well, you can of course use the .remove function as we saw, but this is going to do something with our data list. You see, if we do remove 5, we are going to have 1432 as the final list. Now let's go ahead and write down the indices for this. 0, 1, 2, 3. Do you see something that went wrong? As soon as we removed this 5 over here, this index 2 also got removed. So all of the elements got shifted by one index. This means that to remove this element, we also have to fix all of the indices after it. Now this does not sound too efficient, does it? It's actually quite cumbersome. So we're looking for a way that can help us do this removal operation with ease. And what we are going to do is we are going to do a swap operation. Now this is a very important part of this video because this is so commonly used in these kind of problems. Whenever you are stuck in this kind of problem, always think about this swapping kind of thing. Okay, what does this mean? What it says is, we know that removing 5 from here is going to be a pain, right? It's going to shift all of the indices. That's not what we want. How about this? How about we swap these two elements first? How about I make 5 in the place of 2 and 2 in the place of 5? So what I'm going to do is I'm going to say the array list is the data list is now going to be 1, 4, 2, 3, 5. Now we only have to change 2 indices at this point. This is the index 2 and the index of 5. So this now becomes, instead of 2, it is becoming 4, which is this value, and this 4 becomes 2 instead. Make sense? You can actually verify it and you can write 1, 0, 2, 3, 4. Okay, feel free to verify it now. Now the thing is, it makes it insanely easier for us to remove this particular element. See, the goal here was to remove this 5 element, okay? And we have messed around with the structure in such a way that the 5 comes at the last. So it is very easy to just do list.pop now, which is not going to cause any trouble. The only thing we really changed were these dictionary indices, and the swapping thing happened. And we were beautifully able to pop this element at the end. And we can just cut this out at the end. Okay, this will make a lot more sense if we actually write it down. So let's actually formalize this. We're going to remove this self.data.remove function because that is useless. And we're going to do the swapping operation first. So let's actually extract out the current element and the last element. The current element is going to be nothing but the self.data sitting at the current index. And the last element is the self.data sitting at the last index. Now we're going to swap both of them. So I'm going to say self.data of the index is now last, and self.data of -1, which is the last element, now becomes the current index. All I have done in these 4 lines is to swap both of these current and the last elements. This is this green thing over here. Now we can do this list.pop thing. We want to do this towards the end, so we'll do self.data.pop over here. and we will remove this dictionary listing. Before that, we also want to do one more thing, which is update these indices to be the correct ones. So, I mean, this one we just remove, so that's not useful. But this one is the most interesting one because I want to be able to go to this element, which is now the, sorry. So I want to go to self.data of this index. This is the current value I'm looking at. This is the value 2. And I'm going to say that self.dictionary of this element is now going to be the index of index itself, right? 2, this 2, which is the value 2, which is the self.data of the index. After we have swapped, this index is no longer the current, but the last. And the self.dictionary of this guy, which is the element 2, which is this part, becomes the index 2. This is the index 5 was initially at. And in this way, we are done. Let's go ahead and run some sample test cases. And we'll go ahead and submit this guy. Cool. So this gives us a runtime which is much better than if you try to convert it to a list and then return random.choice. Much better runtime. You can actually bring it down to 405 milliseconds. Anyways, this is it for the solution to the problem. Insert, delete, get random, order of 1. If you like this video, if you like the explanation, give it a thumbs up. If you dislike it, give it a double thumbs down to really let me know. If you want more of these videos, subscribe. And as always, thank you so much for watching.